Hello, my name is Shipei Xing, a PhD student in Dr. Tao Huan's research lab in the Department of Chemistry at the University of British Columbia. This video introduces BUDDY, our newly developed informatic tool for accurate molecular formula determination using a bottom-up approach. The schematic workflow of BUDDY is shown here. BUDDY takes metabolomics data and first performs metabolite annotation via routine MS2 spectral library search. For the features that don't have annotations, bottom-up MS2 interrogation is conducted to accurately determine their molecular formulae. Even for unknown metabolites that have not been reported in literature, their molecular formula can be produced. Finally, BUDDY incorporates an experiment-specific global peak annotation to further improve annotation accuracy through peak-to-peak relationships. To dig deeper, the main advantages of our bottom-up MS2 interrogation are shown here. First, we proposed a bottom-up approach to acquire MS2 explainable candidates. And this allows us to drastically narrow down the search space, reduce computational cost, and improve efficiency. We also designed a machine-learned ranking using over 30 MS1 and MS2 features to enable highly accurate formula determination. Moreover, we incorporated Platt scaling for false discovery rate estimation, and this provides significant control. Combining all these efforts, we were able to discover thousands of molecular formulae that are not archived in any database with high confidence. And to download BUDDY, you can go to our GitHub account. Here you can download the latest version. In case you have any questions, we also offer a detailed user manual on the GitHub page. And for installation, you simply unzip the package, right-click the install.ps1 file, and run with PowerShell. During the installation, you might be directed to enable the developer mode on your PC. Just turn it on, and you are all set. This is the main page of BUDDY. To start with, you can create a single search project. First, you fill in a precursor MZ value. In these text boxes, you can fill in MS1 isotope and MS2 spectrum. We offer demo data so that you can easily follow with. If you check the file, and you'll be able to see it in the feature list. The MS2 spectrum will be shown if you highlight this feature. Also, you can import multiple features coming from metabolic feature tables, MZML files, or MGF files. For custom feature table, we offer a template, and you can download the template table here. Here, we just import the demo table. Before we start, let's go into the details of settings. Basic settings is just an easier version of the advanced settings. So let's just take a look at the advanced settings. First, we have to set up the tasks that we want BUDDY to perform. MS2 library search performs metabolite identification. Bottom-up MS2 interrogation further annotates the molecular formula of unknown features with significance estimation. On top of that, we can do another step of experiment-specific global annotation to reveal peak interrelationships. Of note, global annotation has to be performed together with bottom-up MS2 interrogation. You can further set up other parameters such as mass tolerance, MS2 preprocessing, etc. And notably, we offer an option to include meta scores for the annotation task. This could be helpful in annotating existing formula at the cost of potentially discarding novel formula. And here, we will just check all the tasks for demonstration. For MS2 library search, you are allowed to upload your own reference library in MSP format. And FinHelic library will be used by default. You can also customize MS2 searching algorithm. And here we offer 3 algorithms. You can also customize metabolite identification thresholds, where we offer recommendations based on an acceptable level of false discovery rate. Furthermore, you can restrict the allowed element list, chemical databases, elemental ratios, and adduct forms. We also have raw data preprocessing for metabolic feature tables from MS style and MZML files. Finally, you can set up a specific timeout. And if you're interested in the subformula information, you can check MS2 fragment re-annotation here. After parameter settings, let's go back to the main page and start computation. Check the features that you want to compute, and here we just check all of them and compute selected. After computation, you're able to see all the candidates in the candidate list. We have an estimated FDR for each candidate, so that users can easily apply the significance control. And this database list shows in which chemical databases this molecular formula could be found. The result panel summarizes how this candidate performs in MS2 explanation. The MS2 fragment table lists the detailed explanation for each fragment ion. And if experimental MS1 isotope is provided, you can also inspect the mirror comparison of MS1 isotopes. Specifically, we have a spectral comparison panel here. You can drag and drop features with MS2 available here to quickly check how similar they are. If you performed metabolite identification, the identified metabolites will be labeled as seed metabolites. You can check the MS2 matching quality within the result panel. We also offer the detailed information of the metabolite, which is retrieved via the PubChem API. And this feature connection panel is only available when global peak annotation is performed. For example, this feature has two connections within this experimental run. We consider both abiotic and biochemical connections. And their formula differences can be explained using common biotransformation reactions. And if MS2 is available for both features, a minimum of MS2 similarity score of 0.6 is required to construct a valid connection. To export the results, we provide single export and batch export. Single export works for a single metabolic feature, and exporting batch summary will export a CSV file containing all the features within the selected files. And here we can just export the batch summary. As you can see, for each feature, the top one formula annotation will be exported, together with its estimated false discovery rate. Export detailed results will export a zip file with all the results in a hierarchical manner. And for example, you can see the results for each file, each metabolic feature, each formula candidate, and their subformula explanations on the MS2 spectrum. If you have any further questions, you can check out our user manual, and any issue report is welcome. Wish you a wonderful journey in BUDDY.